Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. My dear students at Rital International Academy, I hope you all remain safe and unharmed at your home. The objectives from this lesson with our journey with light is you will be able to predict the location of interference fringes using equations for double slit interference. Students will understand terms like path difference, order numbers, and like so. Here we have interference of light at double slit. It's a very famous experiment on the last century. It gives us an explanations, definitions for light waves behavior. So double slit, I have two narrow slits. They are so narrow, so you see it sometimes as a one slit. If I increase the spacing, you might be able to see they are two slits. Okay, now it is good for us. So you see it. It is two slits. When we have a monochromatic light, mostly it's laser. We prefer to use a laser light here. I'm able to control it here to here, to control the light here, color by here. So it is a monochromatic. It took only one direction. When it's filled here, we have light goes to the many directions. This is what we call it an interference of light in double slit experiment. Okay, by connecting this lesson by the previous worksheet, you have to know this. When light fall here, we have a constructive interference. This is why it gives us a color. This is what we call a shine fringes or a first maxima. Light shine here, be sure that. But if they shine on a destructive manner, so they cancel each other as we see that on previous video. So there is no light. We are not able to see it. Here again we have a constructive interference, destructive interference, constructive interference, destructive interference. We call this as a pattern. So the first one we have it on here of light coming this way. We call it the first maxima. The first maxima, it is a direct from the slit to the screen. We call this one a second minima. Second maxima, sorry. This is third maxima, fourth maxima, so on and so forth. Okay, the first things after first maximum here, they cancel each other. We call it first minimum. We call this second minimum. We call this third minimum, and so forth. And again, I hope, let us see how wavelength affect on the number of slit. Let us increasing the number of fringes here. Sorry, let us increase it. When we increase the wavelength, we have a less number of light constructive or destructive manner. Increase it more. Okay. Let us see how spacing affect on it. We decrease spacing, we have a less number of light, less patterns we have. We increase it here. We have, so sorry here, I just manipulating on spacing between two slits. As I increase the distance between two slits, I have many constructive light here. We call this equation, this is what we going to use if we want to count the maxima. D is the spacing between slits, how the distance here we calculated. Theta, they put it alpha. In your book you will see it as a theta is an angle, how they in this angle is differ that angle. So we're going to calculate it. K, order of the maximum. K is order of the maximum. We call. So my students, this is how we're going to use this maxima, d sine theta, k. In your book you might see k is m instead of k, but don't worry, they are all give same meaning. D is remain, D is in meter, k is only a number, does not have any unit. Lambda is on meters. Sine theta it is an angle. So let us take an example here. We will trust on the equations and we will use it in order to have the answers for our question. We have sample problem here. So the distance between the slits is 2000 nanometer. If the second order bright fringe, it's m equal to, so they give it to us. It is m equal to. Here it is m. In our equation we're going to use is k. No difference between them. It's only the difference between American and British school here. It's measured on a viewing screen at an angle of 36.86 degrees from the central maximum. Determine the wavelength of the light. So we have this distance 2000 nanometer. K or m, there's no difference, equal to, they give us the theta is 36.86 degrees. They're asking us about lambda. We're going to use this equations, d sine theta sine alpha equal k or m, no difference between both them, times lambda. Substitute that directly in the equations. 2000 times 10 to the negative 9 equals sine of 36.86. 2000 times 10 to the negative 9 times sine 36.86 equal to second maxima times lambda. Divide both sides by lambda. So lambda equals 6 times 10 to the negative 7. We put it on nanometers. Lambda is approximately equal 600 nanometers. Let us see it. Here I have wavelength 600 nanometers. Spacing between slits 2000 nanometer. As you see, the spacing between two slits here. And this angle, it is equal 0 because it's asked about first minima. I asked about second. Here I have 0 minima, max first minima, second minima. You see it? It is 36.86. It's almost 36.9 degrees. So this is the second. This is the 0 minima. This is the first minima. This is maxima. This is 0 maxima, first maxima, second maxima. So it has a two point here, one of them here, and the other is here. So the angle between this one, 0 minima, and the second 0 maxima and the second maxima, it's equal to the 36.9 degree. So 0 maxima, first maxima, second maxima, and we're using this equations. D sine theta equal k lambda. Okay, what if I'm asking you to find the third maxima? Use the calculations. Use the equation. We use it on the slides, and be sure that the angle would be 64.2 degree. This is the third maxima. Okay, what if I asking you to find the angle of first and second minima? What if I asking you to find the angle of first and second minima for the same conditions? Okay, we know the distance remain the same, 2000 nanometer. K, one of them would be 1, the other would be 2, first and second. And lambda, we calculated already, it is 600 nanometers. So they're asking us about theta. So this is the equation we're going to use to calculate minimum. D sine of theta sine of alpha equal k minus half times lambda. If they're telling us is half, we put it 1 minus half. First 1 minus half, second 2 minus half, and use it. So 2000 times 10 to the negative 9. This is so we use it now. First minima 1 minus half times the wavelength 600 nanometers. You have to be able to use it. 600, 1 minus half 600 is 300. If you cancel this by this, it's become 300 nanometers. You must be able to cancel negative 9 and negative 9 since they are equal on both sides. Now divide each side by 2000s. You will have 300 over 2000s, which means 3 over 20. Shift sign 3 over 20. You will have theta equal 8.62 degree. This is the first minima. On the same manner, if I'm going to use for the second minima, 2000s times nanometers, again I cancel negative 9 from each side, 2 minus half, 3 over 2, and 3 over 2 times 600 would be 900. Divide 900 over 2000s, it will become 9 over 20. Shift sign 9 over 20, you will gain theta equal 26.74 degree. Again, under same conditions, we have wavelength 600, spacing 2000s nanometer, and now we are asking about the first minima. 8.6 we already calculated, as you see in our solutions. The second minima 26.7 degree. Here first minima, again let me here's just explain. First minima here 8.6, from here to here 8.6. Now second minima from this line with this line, it is 26.7 degree, and from this line to this line it's 26.7 degree destructive interference. Okay, try to calculate the third minima. The third minima by our equations. Reassure that the answer must be 48.6 degree. So this is our lesson for today. I hope you all understand it. I will upload a worksheet regarding this lesson. Good day to you all. Remain safe and remain at home. Thank you all, and goodbye.